We are going to look at rationalization of surds. Rationalization of surds. Now, for example, they said rationalize the following. I'll use this to explain what rationalization means. If the equation you're giving, if the surd you're giving have a root of non-perfect numbers, the denominator, that surd is irrational. For example, if you check here, we are having a surd as a denominator. A surd as a denominator, surd as a denominator. So when the surd is the denominator, we said it is irrational. We want to rationalize it. We want to make it rational. This is what I mean. In question 1, they said rationalize the following. 1 all over root 3. So this is 1 all over root 3. Anytime you are asked to rationalize and the denominator is just one value, all you need to do is multiply. This same thing as saying 1 all over root 3 times root 3 over root 3. If you're asked to rationalize, just take that root, multiply it up and down. Do you get? Just take the roots here, multiply up and down. Because you know, root 3 will still cancel root 3 and will still end up with our 1 over root 3, right? So when they say rationalize, just use the denominator now, the irrational surd now, to multiply up and down. So with this, we are going to have 1 times root 3 is what? Root 3, right? Good. All over. Root 3 times root 3 is what? 3. Thank you. Remember that root 3 times root 3 is root 9, which is 3. Remember the general form I gave you, root a times root a equal to a. So root 3 times root 3 equal to 3. Here's the answer. You've rationalized the denominator. You've made the denomination rational. 3 is a rational number. Do you understand that? Question 2 there, say rationalize 10 root 2 all over root 5. Who have gotten the answer here? What's the answer? 2 root 10. Okay, let's see if it's correct. Let's solve it together. Now, 10 root 2 all over root 5. First, when you're solving something like this, they say we should rationalize. So this is same thing as 10 root 2 all over root 5 times what? Times root what? 5 over what? Root 5. Anything that is here as the denominator, that's what you use. Root 5 times root 5. And in that case, we'll be having 10 root what? 2 times 5 is what? 10, right? So we'll be having 10 root 10, right? All over 5. Good. Now 10 divided by 5 is what? So we'll be having 2 root what? Is there any perfect square in 10? So 2 root 10 is our answer. Let's solve number 3 together. 2 root 3 minus 6 all over root 3 plus 3 over root 27. Right? Okay, so we are good to go. At this point, you know, this is the same thing as saying 2 root 3 minus, we can rationalize the denominator here, right? How do we rationalize the denominator? Individually now. We multiply, we can say this same thing as 6 all over root 3 times what? Root 3 over root 3. This is how to rationalize this one, right? You move on to the next, plus 3 all over root 27. To rationalize this, we say times what? Root 27 over what? Root 27. There are different approaches of doing this. You can use any one. Now, this is the same thing as saying 2 root 3 minus, this is 6 root 3, right? This is 6 root 3 all over what? Root 3 times root 3 is what? 3, right? Plus, this 3 times root 27 all over what? 27. Good. Now, at this point, you know, this same thing as saying 2 root 3 minus, yes, 6 divided by 3 is what? So here is same thing as 2 root 3 plus 3 root. Can we simplify 27? 27, I mean this 27. 9 times what? 9 times 3. All over what? 27, right? Good. Now this is same thing as saying 2 root 3 minus 2 root 3 plus 3 root 3 is what? 3 root 9 is what? 3, right? So 3 times this 3 outside will give us what? So we have 9 root what? All over what? But this thing we've been carrying along since, 2 root 3 minus 2 root 3 is out. Is it not? 2 root 3 minus 3, 2 root 3, this the same thing now. So we are left with 9 root 3 all over what? 27. Is it not? 9 here, 1. 9 into 27 what? So this is root 3 over 3. Or you put it like this. 1 over 3 root 3. That's all. That's everything. You tried though.